Hello, I welcome you again in the next video of searching technique. In the previous video, we discussed about linear search. Linear search is the simplest approach of searching, and it is basically applied when the data is not sorted. So we have already discussed about linear search. In this video, we will be talking about binary search. Okay, so let's start. Okay, so binary search is a topic for discussion in this lecture. This is a very fast method and efficient also, but the only requirement to apply this method is element must be sorted. So if you have a list of data, if you have a list of elements, and if you want to apply searching, then binary search is only applicable if your list is sorted. Otherwise, we have to go with the linear search. So what we are doing in this method, let us understand the logic of linear search. We'll go to the algorithm then, and then we will analyze the binary search. So let us first understand that where we see in our practical life. Uh, we are been applying searching techniques in our day-to-day life. So binary search also we are using. For example, if you are asked to search any word in a dictionary, so let's say you are searching the meaning of the word university. So what you will do, you will pick a dictionary and you will just you are not going to search from the very first page that university word is there or not. If you will do like this, you will be spending a full day to search for a word university. But what you are doing is you are randomly opening one page, means you are just opening uh, randomly from some position, because you know that university is somewhere at the last, so you will be dividing your entire dictionary into two parts, and then you will be checking that what a particular page is being opened, if it is P or Q or whatever. So depending, you are looking for university means you're looking for a word that starts with U. So you will understand if your word, if the page which is showing the words on P, that means you will be searching on the right side. Now, binary search is the approach that is not exactly work like this. So when we search a word from the dictionary, we are not exactly applying binary search. But we are using it in similar to binary search. In the binary search, we are dividing the element exactly into two halves. So when you are looking any word in the dictionary, you are not dividing every time into exactly two halves. So this is not exactly the binary search, but it is a similar kind of approach. Okay, so how actually it works? Let's see. So in this approach, we are dividing the given list, whatever the list we are having. We divide the list into two halves. We will search the mid element. We will search the mid index, and we will check what is the element exists at that index. If that element is the element which you are looking for, then it is said to be a successful search. If the element which you are looking for is not matching with that element, that means you are still not able to find your search, and then you have to move to the next step. In the first step, you are actually unsuccessful. Then in the next step, what you are doing, you will not working with the same list of element, but you are dividing into two halves. Let's take an example to understand. So let us, I have an element, 12, 19, 32, 47, 88. Now I am looking for element 38. That element 38 exists in this list or not. So what I am going to do is I will be looking for the mid element. I will divide this and I will go for the middle position. So this is the mid index, and I will compare, is this 38? No, this is not 38. That means my search is not successful, but still I'll move to the next step. Now what I am going to do is, in the next time, I am not going to search in the entire list, but I am going to divide my array into two parts. This is my first part, this is my second part. So if the element which I am searching is more than this value, the mid value, then I will search in this. If the element which you are searching is more than the mid value, you will search in this part. If the element which you are searching is less than the mid value, then you will be searching in the left part. and again you will be applying the same approach. You will divide into two parts, and you will be checking the minimum value. So for example, we have two elements. Now let's say we have divided into two parts. This is your mid value, and is this equals to 38? No, this is not 38. That means you are unsuccessful in your search, and you will stop. There is one point that might come to your mind, that what happens if the size is an even number. Then what is a mid element? Like here, when we have two elements, 47 and 88, and when I say we'll go to the mid index, then what is the mid index? How we can find this? So everything can be resolved. We have an algorithm, and we'll see how it will work. But here I am trying to give you the basic idea that what is the approach of binary search. So the approach is divided into go to the midpoint, mid index, compare the element. If the element is found, your search is successful. Otherwise, you have to move either to the right or to the left. This is the basic approach of binary search. Now, how to implement this search? So we have an algorithm. We'll see. Okay, so this is the algorithm. This algorithm you can convert into a program, and you can also write this code in using C++ or Java, whatever the language you are using, and then you can also see the behavior, that how it works. Is it working or not? So what is required every time whenever we talk of algorithm, you must be aware about the input that you need to provide and what exactly you are expecting. So the input is, we are providing the array of element, and we have to provide what element we are searching, and also you need to provide the size of the array. Now here we are assuming that our array is sorted. So again, keep in mind, if the array is not sorted, then this algorithm is not going to work. What we are expecting that the element is found or not. So when you run this procedure, you will get the output that the element is found or not, and also you may be interested in finding the position, that what is the location where this element exists if the element is found. So this is the procedure, a binary search. We are providing the three values. One is the array, the element which you are looking for, and the size of the array. So let's take an example. We have an array whose elements are, let's say, 2, 5, 7, 6, and 12, and the size of the array is 5. So here the maximum size, the value of this variable is 5. And let's say you are searching 6, you are searching this value, you are searching 6, so your data is 6, and the array name is, let's say, AR. So you have to pass the three parameters. The name of the array is the array, the element you're looking for, and the maximum size. Here we will declare some variables to do some, to manage our logic. We have one variable lower, which will maintain the lowest index, the first index of the array which you are working on. So here, this is our primary array on which we are working. So initially, this index is 0, 1, 2, 3, 4. So the lower value is 0. Upper is max size 1 minus 1, because array starts with 0. So if you have array of size 5, then the largest index is 4. So this is a array of size 5, and the largest index is 4, which is max size minus 1. So upper in our case is 4. We are also using a flag. Flag we are using to manage the status, that we have find the element or not. So initially we are saying we have not found the element, and we are keeping it as a false. Now we have a while which goes up to here. So the scope of the while is from here to here, and this is all the body of the while loop. So we are comparing the two conditions. We are checking the two conditions actually. So if lower is less than equals to upper, so till the value of lower is less than equals to upper, and the flag is false, then only we will perform this operation. If any of these two conditions becomes false, then we will exit from this while loop. So mid equals to lower plus upper by 2. So here lower, so we will see mid here. So lower plus upper by 2, 0 plus 4 by 2, that is 2 here. So this is the second index. Now let's say we have one more. One thing we have missed here, actually, to apply this algorithm, this must be in sorted order. So this is not sorted. So let us make it sorted. So 2, 5, 7, 16, and 22, and let's say we add one more element, 28, 28, and now we have index 5. Okay, now why I have added one more element, just to make you understand that how this mid work. So when we have this kind of scenario, we have only 5 elements, then mid is 0 plus 4, that is 2, we get this index. But let's say we have 6 element, in that case lower is 0, upper will be 5, and 0 plus 5 by 2 is 2.5, and here we will put our logic, take the floor of the result. That means when you get 2.5, we will take the floor of this, we will get 2. So that means when I have this scenario, this is my array, and I want to find out the mid. So my mid is index 2. I hope you understood now. Okay, so we will find the mid. Now we will check if the data which is kept at this index is array of mid, means we are looking for this value. Keep in mind, data is 6. This is the value which you are searching for. Now the mid is 2. We will look for this value. Is this value 6? So I write here array mid. So it means I am looking for the value at index 2, which is 7, which is not equals to the data which I am looking for. So this condition will be false. If array mid equals data condition is false, so we will skip this and we go to the else part. In the else part, we need to proceed further. If you find the element here, that means you have got the element, your search is successful, and you will exit. But if it is not successful, you have to check with the remaining element. So what we are doing, we go to the else part. Here we check if data is less than array mid, means the value which you are looking for is less than the value here or more. This is 16 because this is a sorted array. We are looking for 16. This is 7. So that means the value which we are searching is more than this mid value. In that case, what we will do, this condition is actually going to be false, because the data value is actually not less but more. So we will go to the else part, lower equals to mid plus 1. So in that case, we will be going to set lower equals to mid plus 1, means the lower will be 3 now. So now in the next iteration when we work, the value of lower will be mid plus 1, that is 3, and the upper will remain the same, that is 5. So now we have a new array, this 3 to 5, 3, 4, 5. The lower is this and the upper is 5. Okay, so now we will go back. We have executed all these statements. Now we'll go back and we'll check the while condition. Lower is less than upper, yes. The lower is still 3 is less than 5. This condition is true. And the flag is also false because we have not changed the status. So both the conditions are true. Then we will go inside the loop and we will find the mid again. Mid is 3 plus 5 by 2, that is 4. So your mid is 4, that is this index. Now we will look to this index, the value at this index, that is array mid, which is 22. Now we will compare, is this the value which we are searching? No, we are not searching this, we are searching 16. So that means this condition is not true. If condition is not satisfied, we go to the else part again. If the data which you are looking is less than the mid value, The data you are searching is 16 and the value you get is 22. Yes, this is less. If this is less, then what you will do? You will do upper equals to mid minus 1. So what is mid? Mid is 4. So what will be upper? Now upper will be 3. And what is lower? Lower will also be 3. One thing to keep in mind that when the data which you are searching is less than the mid value, you simply change the upper part. You will simply change the status of the upper variable. Otherwise, you will change the status of the lower variable. So here you can see now we have this status. We have executed all the statement. We go back. Now lower is less than equals to upper. So you can see here lower is less than equals to this. These are true conditions because both are equal. So this will satisfy this condition. And found flag is false. Still the flag status is false. So it is true. Now we will go to this mid part. So mid is what? Mid is 3 plus 3 by 2, which is 3. So you will look at the index 3 and the value is 16. And your data is also 16. That means you have find the element, and when you find the element you will go to this condition. Your array mid equals to data, this is now true. You go here and you will set flag equals to true, and you will go back to the while loop. In the while loop this condition will not satisfied. That means you have to exit from this loop. Actually you have already found the element, that's why you are exiting. Here you will check if the flag is true because already the element is found. You have set the flag equals to true, so you will say the data is found. And also you can mention the position. You will just mention the position, that is it is found at position mid plus 1. So the mid value is 3. That means you have found at fourth location 0 1 1 2 3 4. So whatever the index you are getting, you just add 1 to it, you will get the the position of that element. So index is 3 but the position is fourth position. So I hope you have understood. So let's say um, this element is not 16, this element is, let's say, 18. In place of 16, if this is 18, then how this algorithm will work? We are looking for 16, this is 18, and still it is sorted. So what will happen? So in that case, let's say just go back here, we will find the position of mid. Mid is 3 plus 3 by 2, that is 3. We go to this index, and this will compare this element with this element which is not matching. So and this particular statement is actually not executed. We go to the else part, and here we will find if data is less than the element which you are searching. So data is what? 16 you are searching, which is less than this value. So you will be going to decrease the upper. So upper you will make it mid minus 1. So now you are going to set upper is equals to mid minus 1, which is 2, and your lower is remain the same. The lower will be 3 only, but upper will be set to 2. And you will go back again. You will go back again. You will check the condition. Now lower must be either equal to or less than upper. But now your lower is more than upper. That means this condition is not satisfied. So it will exit from the while loop. You will go here, and still the flag remains false. Because the flag will only become true when you find this element, when this mid value is matching with the searched element. So it is still found false. You will say the data is not found. So this is how this algorithm is actually working, and I hope that you have understood the logic and you will be able to implement this in your program code. Now let's understand that what is the performance of this algorithm. Is it better uh, than the linear search or not? Let us analyze it. Okay, so let's talk about the analysis. We will see that how it is. We'll talk about the performance of this algorithm, and we will try to conclude that it is better than the linear search or not. Such case is big O of 1. Big O of 1 refers to the constant. Constant means independent of the input size. Now, then we have worst case is log n. In the previous algorithm, that is big O of n. Best case is big O of n 1 only in the previous case. One more thing, when we talk about the best case, you must be knowing what is the best case. So best case is a constant time, but also you must be knowing what is the scenario. Like in the linear search, the best case is constant big O of 1, but the scenario is the element which you are searching must reside at the first position. Now, what is the scenario for the binary search? So, when I say best case means it will require the minimum number of operations. So, minimum operations is one operation only. So, the scenario where only one operation is applied and you will get the success in your searching, the scenario when the element which you are searching exists at the center. So let's say we have 2, 12, 19, 32, 81. We have these element and I am searching for 19. So when I start my search, I will find the mid element and the mid element is 19. So I did only one comparison. I did only one operation. So this is called best case scenario when your element exists at the center. Then what about the worst case? Worst case means the maximum effort required, the maximum number of operations which is required to get your answer. In the linear case, in the linear search, that is big O of n, we need to search all the element, but here it is log n. Now why this is log n? Let us understand. So every time we are reducing our effort domain by half. So let's say if you have initially n number of element, then we have, so initially input size is n, and the next time when you proceed means when you if you are unsuccessful in the first step, then next time either you are going to the left side or the right side based on the condition. So your n size becomes approximately n by 2. Still, if you are not successful in finding the element, then your n will become n by 4. So every time your input size is keep on decreasing, and it will keep on going until the size becomes 1. Now this is the kind of the iteration which is actually required in this approach, and already we have discussed in our analysis of iterative kind of algorithms. You just refer to the video where we discussed how to analyze running time of the algorithms, and we have seen here that this is nothing but a log n. So this is big O of log n. So just keep in mind every time when you are either doubling or making the input size half in the next iteration, your effort will be log n. Okay, moving to next. We have some limitations because this search cannot be applicable in all the scenarios. Like linear search, it can be applied in all the scenarios. It can be applied in the sorted list. It can be applied in the unsorted list. But to make uh, apply this binary search, your elements must be sorted. This is one basic requirement to apply this method. The other requirement for the binary search is it is only applicable to data structures which allow you the direct access. Means what does it mean? It means we have certain data structures where you cannot do random access. You can only do linear access. Now, why it is required? Now, in this approach, what you are doing, you are finding the mid index and then you are accessing that mid index. You are comparing this value with the data you're looking for. But we have data structures which will not allow you to randomly go to any index, but you can only move linearly. You have to go here, then here, then here, then here. Then in that case, binary search is not applicable. For example, when you will work in the linked list, so linked list we will be discussing in our coming classes. Linked list is a sequential data structure where the random access is not possible. Like in the array, you can move to any index, whichever index you want to work on. You can move to 1, you can move to 10, you can move to 20. So this is a random access. But linked list is a arrangement of element which will not allow you to move in this fashion. So it's a only sequential kind of access is possible. So in the linked list, binary search is not possible. Just keep this in mind. And whenever you are implementing your program, so you need to be kind of aware about what kind of data structure have you used, and then what kind of search is applicable on that. So this is all the basic information which is required that every programmer must know about about the searching techniques. We have already covered linear search and binary search. In the next video, we'll be talking about the sorting techniques. This is all for this video. Thank you very much.